The focal length is a very important parameter of a lens. If we know the focal length, we can use that to determine the image position. Just like we did with mirrors, we can use ray diagrams to determine the focal length of any given lens. Ray 1 in our diagram is drawn parallel to the principal axis. This means that it will be refracted through the focal point behind the lens. Remember when we said that the focal point for light passing backwards through the lens would be the same as the light passing forwards? Ray 2 is drawn so that it will refract through the lens so that it is parallel to the principal axis. This means that it will have to pass through the focal point on the front side. This is just sort of opposite of what Ray 1 does. Ray 3 then is directed towards the very center of the lens. At this point, the two surfaces of the lens are essentially parallel to each other, so the ray leaves the lens at the same angle at which it entered. As such, the ray pretty much travels straight through the lens. The point where the rays meet is the image point for that object. Because the refracted rays would actually pass through the image, it is considered a real image. And if we were to put a white surface at that point, we would be able to see the image projected there. We can do the same thing for a diverging lens. Ray 1 in our diagram is still drawn parallel to the principal axis. As it leaves the lens, it is bent away from the principal axis. But if we trace the ray back to the point where we would perceive it coming from, we see that it appears to originate at the focal point of the lens. Ray 2 is directed towards the focal point on the back side of the lens. This will cause it to be refracted parallel to the principal axis. Again, if we were to be looking directly at this ray, it would appear to be coming from some point parallel to the axis. Ray 3 then is directed towards the very center of the lens. Again, at this point, the two surfaces of the lens are essentially parallel to each other, so the ray leaves the lens at the same angle at which it entered. As such, the ray pretty much travels straight through the lens. The point where the three rays meet is the image point for that object and is found on the same side of the lens as the object. So now the rays of light forming the image do not pass through the image, so it is a virtual image.